Hello, everybody. Welcome you all for the session on virtual reality and augmented reality. And like, there's a lot of stuff which has already been hyped and hope. Like, there is still a improper definition about whether this reality and artificial intelligence and coming together will they make an human more obsolete or something. We don't know that, but now we are with Priyanka Sharma teaching ourselves and learning what is it all about working with this technology today. And also mainly there are a lot of stuff which is involved in things like okay, how can we involve this in the gaming, how can we involve in this technology and that technology. But trust me, it's one of the best things to learn today. And also a brief introduction about our community. This is Easy Dev India. In the scroll there is always that Telegram channel which is going on, so this is a communication pod for you guys, so you don't have to miss out any of the sessions in the future and things like that. And also, this is our website azdev.community, so do check it out. I'll link it down in the comment section here. And also, anytime if there is an event, of course there will be a pop-up of this symbol and you just can hop in and start learning from here. And basically our community basically aims in upskilling you all as a community and giving you all the same set of knowledge which can be accessed and sometimes which can't be accessed as well. So this is where we come in as a community and we start working, and we are 9,000 plus strong members, and we are very close to 10K. So make sure that you go hit on our meetups channel and just come there. And we are a one strong community, by the way. And it's all mixed up, but it's all aligned to your needs itself. So we all have different sessions from different experts from the community. So you go there and check out, and also do join. There are some partnering communities. Go ping them up, get the sessions done, or else come to us. We'll get the session started. And also, there are some events which are already been here, and also these are the past events, so you guys can go check it out on YouTube. And also community organizers are here, speakers are here, and lot, man. You guys can start working on it. So over to you, Priyanka ma'am. The stage is yours.
All right. Thank you. And as usual, nice lineup of events here.
Thank
All
you, ma'am.
right. So, okay. So we'll start. Can you see my screen?
Yes, ma'am.
Can you see my screen?
Yes, ma'am.
All right. Okay. So let's jump into mixed reality design development, and fondly called as MR. The types are augmented and virtual reality. So we'll jump into it. So when we say MR, right, mixed reality, what is it? So that is actually, you go back to all your Avenger movies and your sci-fi flicks and just look at all the cool animations which Iron Man pulls out, right? Like all the screen where he's controlling the robot, holographic projections, machines and humans coexisting together, and 3D interactions with the devices, with screens. You just tap and you draw diagrams with your fingers, hand movements, gestures. So all that and much more. I don't want to put it into text, right? You already know, we have been experiencing it. It has been a integral part of our sci-fi movies and our DC universe, right? So that all with whatever you cool things which you see, and you're able to interact, that is all mixed reality, right? Okay. And this field, because of the coming together of all the facilities which are provided by artificial intelligence, which is vision, speech, text, right? And we saw, like the other day, we saw a lot of cool things about sound simulation and all of those things possible with AI, even trying to simulate touch and smell and I mean, not only vision and speech, but also all of the other senses as well. So blended with all of these things, animations in 3D, mixed reality is actually I mean, it's not something bounded by any limitations. I mean, only what our own imagination is our limit, right? Like there are boundless possibilities with mixed reality. Okay, so the basic concepts of mixed reality are, it's a spectrum. Okay, so I mean, it blends your physical, your real life things with the digital. Okay, and then with that blend, it is something like a next chapter in evolution of human and machine interaction. All right. When we talk of mixed reality, it cannot be without a holographic projection, right? So without holograms, like how do you blend your physical and unreal worlds, right? So how physical and digital world, what, how do you blend it, how do you uh, make it appear as if, someone who's not here is actually present here, and leverage that a thing in your real life applications. So that is something which is possible using a hologram, and hologram is possible by the use of devices which you which are HoloLens and other mixed reality devices, right? So HoloLens is one of the Microsoft offerings which lets you create holograms, holographic projections, right? And holographic projections are not static, just 3D projections of 2D objects, right? So they are actually something which can be able to respond to your gestures. They can respond to your eye movements, and then accordingly, so it's like the responsiveness to stimuli. So given the stimuli, like you're trying to touch it or you're trying to do some gestures, and then the holographic projection will respond to your stimuli accordingly. Okay, and then Microsoft has amazing learning modules on mixed reality. I'll be sharing the link shortly, like all the links all together I'll share at the end, right? And of course, like there are some design criteria which you need to keep into account when you're designing mixed reality applications. So it's not something as simple as just charting out your UI UX which you do for your web apps, right? I mean, even that is not simple. I should not undermine that as well, especially with the, a responsive UI for different devices for different resolutions, right? So yeah, I mean, if in 2D, if that is such a challenge, just imagine the challenge which it would pose in 3D. And given the variety, the myriad customers who consume these mixed reality applications, right? So most of them will be like non-technical users, like mixed reality deployed in hospitals, mixed reality. Hey, did I lose my audio? I hope not. All right. Okay. So yeah, just let's continue. Yeah, so mixed reality deployed in hospitals, mixed reality deployed in other product companies for training and stuff, where the user is not tech savvy. So just imagine, like the design process has to be accordingly procured to cater to all these variety of consumers that are actually interacting and consuming our mixed reality applications. Okay, so when we talk of mixed reality, right, these two words crop up together more often than not, which is augmented reality and virtual reality. So, today let's take this time to sort of understand the differences between AR and VR. So, when we talk of augmented reality is something like adding to your current experience, okay, to make it sort of to make it sort of how should I say, enhance your experience. So when you're saying augmented, your current reality is enhanced or added on by the addition of certain extra dimensions. Okay, so that need not be something like a holographic projection, or some entity which is there. It could be normal things like just a sound device. So normally, I don't know if you've gone into those Universal Studios experience, where you have this 5D movies, right? So high dimensional movies, where the movie is playing on the screen, and then let's say the characters, they are throwing water, then the water comes and sort of you feel the water around you. Or like if there's now you see all these sci-fi sound devices, right? So they have that additional real sound or real 5D sound or real, I don't know, 18D sound and those kind of things. So that is kind of giving you an enhanced experience. That is augmented reality, right? Okay, so it is not limited to headsets, right? So augmented reality will not be limited to headsets. Even millions of your typical mobile devices also are able to give you the augmented reality experience, right? So they can project, so your I mean they can project onto walls or tables, your normal mobile devices, and let you interact with that. So I am not sure, some years back there was this video about a pen that can act as a computer. So the pen is actually projecting image of a keypad and a mouse and a screen, right? And then you can type on that and interact with it, right? So augmented reality is just like devices enhancing your experience. All right. When you talk of virtual reality, now virtual reality is something which is, which will get let you have an immersive experience. So it will just create a total new world around you. I'm very sure, like, most of us have walked into the Microsoft store or Samsung store or Apple store and worn those VR devices, and then we are actually into Disneyland or into some roller coaster park, and we are having this ride. So it's an immersive experience. The entire surrounding around you is totally changed, correct? And then you are I mean you are getting that experience as if you are already at some other place. I mean, you don't know the surroundings around you, so you're immersed into a total different world. And that is what is virtual reality. And then it is limited to by the devices on which you're interacting it with, right? So for VR, it won't be just mobile phones, or it won't be any sound or anything. So it has to be an immersive experience wherein you wear the headset, the HoloLens headset in case of Microsoft, and then you will be transported into this total new world, and then you can live your adventure there. Okay. So VR applications are quite a lot, a plethora of applications there. And then because of this total immersive experience, you can have training for firefighters, training for emergency room healthcare providers, flight simulations, even astronauts, right? So how it is out there in space, and how it is zero gravity, and how you have to maneuver yourself out there in the space. All these things are also provided by using virtual reality there, so to get that immersive experience beforehand. All right. So I hope that clarifies about AR and VR. AR is not limited by your any headset or any device which you wear, right? But VR, it is limited by the device, and then it is not an addition to your life. I mean, to your physical 3D life or objects around you. It is a total new world that you are temporarily transported into. All right. So just to summarize our AR and VR, right? So this is the physical world. You are augmenting your interactions with the physical world around you with some sort of device. It could be like, it could be an enhanced sound experience. It could be something projecting in front of you and you're able to interact with it. So that kind of enhanced experience, right? But mixed reality is something like you're transported into a digital world altogether. So a digital world is superimposed on your real 3D world, right? For example, the living room which if I am standing onto right now, or the chair which I'm sitting onto right now, and I wear the VR headset, the HoloLens headset, and then I'm suddenly, my chair is now this seat belt for a roller coaster ride, and I'm in a roller coaster park and having the time of my life, something like that. So you're transported into the digital world. Augmented reality just augments your physical world with enhanced experience. I hope we are clear on that. Alrighty, understanding holograms. As I said, mixed reality cannot be complete without holograms, right? So that is a and the most important concept. Of course, everything that follows, like designing experience and 2D projections, 3D projections, and storyboarding, and everything follows follows our principle for, follows the concept for having holograms. Okay, so holograms and holographic experience aren't science fiction anymore, and we all agree that, especially if you guys were a part of Microsoft Ignite as audience, or in any sort of participation, you must have seen and heard about Microsoft Mesh, and there's a lot of hoo-ha going about Azure Percept as well, which which are going to be soon a part of our digital experience as well. So now we are all remote and working, and now soon all this is going to be a part of our teams meeting experiences as well, right? So yeah, so the point which I want to drive home here is all these things are not science fiction anymore. Okay, so holograms, what are they? They are just digital objects that appear in the real world around the user who's wearing that HoloLens headset, right? So again, holographic projections are maybe sometimes it can be capable by devices like your advanced watches or advanced glasses, right? So some years ago you had that concept of Google Glass. So those advanced type of devices which are able to project objects in 3D, right? Holograms are made up of light and sound, so it's just light play, correct? So it is just, I mean, refracting and reflecting light correctly in correct angles to construct a real life image of that virtual image or virtual replica of that person in 3D, right? Then you can program because at the end of the day all these AR VR everything are just programs, right? So they can be programmed to interact with users. Okay, so interact with gestures. All right, so people who are aficionados of games, right? So your Xbox 360 or PS4 or Y console. So some years ago you had those consoles able to sense your gestures. So much the same now, it is a physical manifestation of you in 3D, in the digital 3D, which is able to sense all these gestures and interact with you accordingly, right? And holograms can be static as well. Okay, so you can maybe pin them to a location. So for example, if I wanted to have a holographic home, right? So I might just as well have a very empty room with no furniture, and all my furniture is actually holographic projection. But now I'm used to having my cupboard at a certain place, my my computer or my working place at a certain place, and then I can pin those holograms to location so that I know where to find them the next time I come around, right? Or they could be also a dynamic. Okay, for example, like whenever you are entering a meeting room, and then however you are dressed as, you will appear as a 3D holographic projection to the other user, or the virtual meeting room on which you are interacting, correct? So you can have spatial anchors to anchor your holograms, or you can have your holograms interact with you. Like for example, you can picture yourself for as picking up a holographic image of a ball. Okay, and then you can actually bounce it, so it knows to react to that bouncing gesture and it will actually bounce. Or then again going back to so forgive my Avengers references, right? But again going back, so you can actually see like they can pick up something if using that holographic projection, and then place it somewhere, and then insert some, click some button, and then something happens, right? So all those interactions can be also done by holographic projections, can be static, can be dynamic, correct? All right. Before we go to 3D design challenges, I don't want to bore you with more theory. Let us have a quick look at some awesome mixed reality applications which are currently being developed, right? And alrighty, let us look at sample apps, right? So there are two basic frameworks for developing and designing 3D motion in 3D. So one is this Unity, okay, and one is Unreal. So you can code apps in either of those. So right now, we are working on one IoT edge project, so Internet of Things, and deploying objects and programs on the edge, which is Azure IoT offering. Okay, and then we are actually working with the Unity here to simulate movements of a person going up, walking up and down the stairs, and the transmission of coordinates of that person real time to let us know whether he's staying on course for the route which is planned out for him, or he is digressing from the course of his route, right? So yeah, so we are using Unity to sample his 3D movements. Okay, you can also have Unreal. Anyways, enough of that. Let us look at some of the applications which have been developed using HoloLens. All right, and I would really appreciate and encourage you to go here and check out all these amazing things. I'm going to play this video, right, and prepare to get blown off your seats. All right, so yeah, just I'll let me start, right? So before I start, just a quick, this is a periodic table. All right, so all the periodic table elements listed out, and then you can actually, so this is the holographic projection. All right, so it's a holographic projection. I'll just maximize the video. Okay, so this is the holographic projection of your periodic table, and then you can basically point and click at any of the element here, and then it will give you its properties and its molecular atomic weight and composition, and you can actually see that atomic structure of that particular element, right? So you can actually see how many electrons it has, and what structure it is, what is the molecular structure, their atomic structure there. Okay, and then you also see, for example, if you're clicking on xenon here, then it's a noble gas, or it's a polyatomic, or it's a non-metal, or it's radioactive, stuff like that. All right, so just look at how cool this is. Okay, and if I mean, I wish that I was taught chemistry this way. I would have found it much more interesting, right? I mean, sure it's for all of us. Okay, so yep, here goes. You're picking out xenon, and you can see actually the molecular structure for that. You can now you can magnify it. Cool. I'm no more interested in xenon. Let me look at mercury, Hg, which is hydrargyrum, and atomic number 80. Now let me look at the structure of mercury. Okay, legions are there. Radium, and similarly, it will give us the melting point and everything. And maybe now I'm bored, I want a different orientation, so I want a cylindrical representation of that, right? Or maybe a spherical representation now with the, me surrounded in a sphere of periodic elements. All right, so yeah, this is one of the coolest demo which I could see. Let us look at another thing then. Let us look at another demo. Okay, so yeah, let us look at this one, surfaces. So what cool things you can actually do with surfaces? So this is just a sphere, a 3D sphere, and then just look at all the gestures and possibilities which you can do with this, right? So let us play. So my hand gestures. Okay, so now, right, so now I'm actually interacting with broken pieces of that. I can see heat map on that sphere now, so it's all made up of colors for me. Now it is a jello, right? I'm actually interacting with that. Now it's a glowing, scorching ball of fire. Now it is covered with ice, and as I move my hand over, it is yeah. Now it's a musical sphere. Cool, right? I mean, the hand gestures interaction, and it is just just a bare metal sphere, and just with hand interactions you're able to do so many things on top of that. All right, another cool thing, let's look at another cool thing, which is correct, MRTK. Okay, so this is the MRTK examples hub where actually you are given lessons of how these things are actually designed, right? Using the mixed reality toolkit. MRTK stands for mixed reality toolkit. So actually how these, for example, hand interaction example, tooling examples, bounding boxes examples. So all of these and much more you can have. I mean, you can interact with here. As I said, all the links at once I'll share at the end today. All right, this is the Galaxy Explorer. Okay, in Galaxy Explorer basically, all right, yeah, so Galaxy Explorer basically you will see that yeah, so this is actually, it is actually giving you about direct manipulation, so how hand gestures and how you're programming, two-handed manipulations and bounding boxes and rotation and all those things also here, right? So this is how the design principles are going about for mixed reality applications, correct? Okay, so let us have a quick look at this.
Ma'am, you're not connected. You're not connected. Yeah, now it's perfect.
Yeah. Okay. Sorry. Where was I? Correct. Making of the Galaxy game, right? So this is basically, it shows your interaction with the Galaxy and how you are programming the elements there. All right. The video is taking a bit of time to load. Yeah, anyways, yeah, okay, so maybe we'll give it time to stream, and then I'll show it to you. So let's move on till that time. Okay, there are a lot of other cool things to see. So now, when you've already seen all these beautiful sample applications like the periodic table design or the 3D interaction with the sphere, right? So when it comes to designing mixed reality apps, you have this 3D design challenges, right? So which is designing for three dimensions, and then as I already mentioned, right, it comes with its own set of shortcomings, limitations, and it's much harder. So you, for your normal web applications also, like few years ago you had very limited tools to actually do those, but now you have so many frameworks and you have so many beautiful libraries, and you can have a variety of controls for the user to interact with. So same way, so there are some toolkits like Unity and Unreal available for 3D designs, right? But there are certain design principles to be followed here. Like for 2D we have this bootstrapping and responsive UI and CSS governing principles. So much the same way for 3D also you need to follow certain design principles, okay, for actually having your team adhere to certain design criteria and following some standard design principles, okay. So when you're designing and developing in mixed reality, you have three aspects, which is body storming, acting, and storyboarding. Okay, what are these? Body storming is, as you can see in this picture here, you are actually creating prototypes of what you want your 3D apps to be, right? So it's a process of prototyping interactions. Okay, so maybe I'm building a game wherein it's a 3D table tennis, right? So maybe now holographic projection should be able to play table tennis with me. So then I have to program all of those things, like teach it all of the games, the simulate the table tennis racket, the table tennis ball, and teach it to respond to hand movements and all of those things, right? So before even I go to the rules of the game and what game it is, I have to design I have to design the holographic elements of that. So as you see, they are building here the 3D models here actually, right? So the goal of all these body storming sessions is to actually get input, right? So you're performing some actions, and how that actions will be interacting with the end user, and what are the end user reactions for that action, and how it is going to operate in the 3D world. So that first process is called as body storming. Second is acting and feedback. So now once your rough, ball and stick models are ready, so your rough models are ready, then you're actually trying to put them into interaction with the end user. Okay, so some third person observer or actual end user, and then try to see that how it is now live in the real world. Okay, so especially, this acting and feedback is very essential when it comes to your demonstration to non users, right? So what basically happens is, if you are going to have a application for hospitals, then it would have, I mean, it would be of immense help if you could have a doctor actually, or a surgeon sitting there and then giving you feedback of how that application, he will interact with that application, and how that application would, react back to his actions, right? So this is your second acting and feedback. Okay, and final one is storyboarding. So storyboarding is now actually sharing the insights with the end user. Okay, so when you're convincing stakeholders, you need to have some sort of story in place, where you can actually share the insights with the end user, and
or for interior design,
Um,
then just
yeah,
imagine like
you were muted for from past 1 minute.
no, I am unmuted, right? I just
You're
unmuted myself.
unmuted, but you were not on the stream
Oh,
for one
so who
minute.
will add me?
I added you.
Oh, okay. Okay, all
Now,
right.
can you start from 1 minute from prior that?
Sure, sure. Okay, so I
Last
was
slide.
talking. Okay, right. So I was talking about action and feedback. Okay, so for training for 3D use cases. Okay, so action, acting and feedback. Acting and feedback is basically when you are done with your body storming, where you are building your rough models, right? Then you're actually deploying those models in real life. Okay, so you are checking out the interaction of those models with the end users. All right, okay, so what happens is, basically here you are going to take the feedback of those users on your actions. And especially this works in case where, if you're deploying, let's say, your mixed reality application in a hospital environment, then having a doctor or a nurse or a hospital person as an observer, and then giving you feedback on how the mixed reality app is going to act with the doctor himself, and what are the inputs and possible reactions. All those things can be discussed. All right. So when you go to storyboarding, that is the final step wherein you are going to present now your trailer for the actual application. So once the end users, once they wear the headset, then they are they get a sense of what they will get via your applications. What is the benefit? So once you wear that, what is the actual story, which immersive experience which you're trying to fetch them. Okay. Most of the common use cases are design prototyping, of course, like real time collaboration of people for designing certain equipments and cars or whatever that is, scientific equipments. Training and development, as we already discussed, flight simulation, firefighting, astronauts. Geospatial planning is like the, let's say you wanted to have your interior decoration done, then just imagine, like the get an immersive experience, like this is what will happen if your cupboard is placed in this location, and you had I mean your garden landscaping was done xyz. So without having to do any manual intervention or manual execution or building sample small models, just by the help of mixed reality, you can just envisage how your interior will look like, or what could be the potential location of your stores. Urban planning, right? Sales assistance, correct. Field service is again like mixed, because of mixed reality. What happens is, if you're not being able to be present at the customer site for redeeming certain complaints, right, then again with the help of field services you can actually try and see, like get a better view, a 3D view of the customer's issue, and try and guide him without having to pay a field visit. Like if it's a router issue or a Wi-Fi issue, much like how you have your IT support and they on call, they are trying to fix something. So this is an advanced mixed reality where you can actually have a holographic projection of the user side of the device or setting, and then try to have a very personalized connect with the user and try to solve the user's issues, right? Productivity and collaboration, all because of all this pandemic era, we already know that productivity and collaboration, it enables us to come closer together and have this actual team meeting experience, even though all of us are sitting at remote places, right? So when we are talking of mixed reality, cloud services and applications, these are a few, like Azure remote rendering, Azure spatial anchors, Dynamics 365 remote assist, and Microsoft Mesh. All right. I just want to quickly walk you through these offerings as well before I, all right, before I actually show you. So mixed reality, here is your Azure remote rendering. What happens basically, this is actually for 3D rendering of your real time 3D rendering of your models, right? So let's say that you're working on designing telescope, right? And then all the parts, how they look like, and different teams coming in together to actually envisage how it is going to look like. So you prototype an actual 3D. So this is a prototyping of that, and then you are going to render it via high-end GPUs into the cloud. Okay, and then all of them can interact. So basically, earlier, if you remember, people, especially engineering drawing, right? So you have those orthographic and isometric projections, right? So much the same here, you are able to, without having those complicated drawings and trying to envision, like, okay, this might be how it will look like and stuff like this. This is an actually 3D rendering of that model. Okay, and then you can collaborate on that. All right. This is the spatial anchors. Spatial anchors is you can actually map, persist, and share holographic content across multiple devices in real world. I mean, at real time, right? So now you can see here it's Tuesday, and then it's Wednesday, Thursday, and then the color goes on changing there, right? So it's now it's Wednesday. So it knows night and day, and then it will like automatically change the calendar, and it can respond to stimuli gestures, right? So in spatial anchors you can program your cognitive services as well, right? Vision, speech, custom vision, computer vision. Then you have 365 mixed reality applications. This is where we were talking of field services, right? So or remote training. So here you are actually now seeing that the mixed reality applications are actually helping them identify and fix the problem together. Okay. And finally we come to this beautiful offering, which is Microsoft Mesh. So this is like actually bringing in people together. So as you see that this person is actually, all these two are, holographic projections, all right, and this is the person actually, and all of them are now communicating via Microsoft Mesh. They are able to brainstorm and collaborate on a problem here. So this is actually like your actual meeting room, but it's just that you're all remotely sitting but connected via holographic projections, all right. So scenarios are virtual collaboration, as you can see here. Microsoft Mesh, engineers brainstorming on the design of a car. The car is also a holographic projection there with all the circuits and the interior machinations. Spatially aware design reviews, right? Help others remotely, right? So if I'm facing a problem, and then I can have my mentor come online and then help me brainstorm some issues. Train and learn together, right? Ramp up paired programming. So paired programming, but sitting virtually at two opposite ends of the world, right? Host virtual meetups, correct? So these are some of the offerings of Microsoft Mesh, right? Coming back to our problem at hand, are right. So when you actually start designing and prototyping, these are the few concepts which you need to understand, which is, there's a coordinate system, but of course, right. So when you are handling 3D images and holographic projections and holograms, and designing for mixed reality applications, you need to learn the coordinate system of placing objects in the virtual realm, right? You need to also know spatial mapping. You need to ensure comfort considerations by creating and presenting immersive content. So it shouldn't be like, if you are standing in a room with the limited dimensions, right? Or it's not a square room, but it's like an more angled room, then your immersive experience should not be distorted. It shouldn't be limited by the limitations of the physical world around you. So all those considerations, spatial mappings, projections, you need to take into account, right? So for all of these, I'm going to share a link with you all for enabling you to do that. Okay, so you have certain, kits here, which is using Unity and which is using Unreal, right? And then you have tutorials for core building blocks. You have tutorials for motion sensors, advanced features, right? So I'll send this out to you, and I'll request Vishwas to, post it publicly on the
Sure.
forum, right? And yeah, and there's another a very insightful tutorial on Microsoft Learn, Microsoft official documentation, where it talks about your design principles for mixed reality applications, right? So this is the getting started principle, in where you need to know how you're interacting with your 3D world, right? So holographic projections and how they are programmed, right? So this is mapping the virtual world onto your physical world, correct? So familiarizing yourself with the nitty-gritties of mixed reality applications, the core concepts. So whether you are developing AR or VR, few core concepts for spatial programming and coordinate systems do apply. So those core concepts, and it is given here. Coordinate systems, comfort consideration when you're doing interaction design. So programming for your hand gestures. So when you're when you're trying to expand a picture, then how to respond to that, or when you're trying to contract the picture and minimize it, then what features should be minimized, and how that picture should, how compact it should become, what should be the amplification, or the minimization of the features when you're depending on your hand gestures. So interactivity, interaction models, right? So hand motion controllers, voice input, eye tracking. So if you are, for example, if you are programming an application like Microsoft Mesh for virtual collaboration, then of course, like, as and when you speak, and you're looking at other people, they should also respond to that sort of a visual stimuli, right? So eye gaze and gestures, head movement, correct? And user experiment elements. So where the user is going to interact with that object, how that user is going to interact with the object. So in real life, 3D, not all objects are square or cuboid, right? Although like in 3D applications we are projecting them, or all of them, as a 3D cube, but then the interaction, how it is going to happen. So what is the contact point, what are the behaviors of common object, like how you would pick up a cup, how you would you pick up a spherical object, how would you pick up a square or a cubical object. So those kind of things are basics of that, right? And then for prototyping option, so for all this 3D prototyping, you have toolkits also, like Unity toolkit is there, MRTK, mixed reality toolkit, Microsoft Maquette. Okay. And much like last time we saw the bot framework emulator, right? So for testing mixed reality applications also, you need not actually have a HoloLens. So right now for our project we are using HoloLens, right? And it's really cool. So you are programming something and then you are using HoloLens to test that. But you have MRTK, which is the toolkit emulator also, emulated toolkit, on which you can test some of the designs which you do for your MR applications. I've posted the links, right? I would also urge you to watch this video out here. Also, I'm posting. Yep, and with on that note, I leave you guys to experiment with your 3D design journey, and I'm ready for any questions.
Yes, ma'am. Sure then. Hey, folks, thank you so much for your time and also for the patience. And I know this is kind of a very, very intuitive topic to you all, but I'm coming up with a session on IoT Hub, Azure Sphere, and also on this digital twin, which is also there from the Azure. Three are amazing set of products. When integrated, can be done amazing stuff. So I learned all these three components. Now I'm trying to integrate it also. A lot of sessions are coming from Azure platforms as well, like a lot of stuff. So yeah, let's just go on with the questions. I think okay, we'll see. Hey, we'll see. How are you? Thank you so much for asking. What are the best resources to start, ma'am?
Oh, okay. Hey, we'll see. Yeah. So best resources to start. I have given you the links, right? So there's a direct link on start to design your mixed reality applications, right? So the link which I have given you, you just go there, and then there's a section called as design, and it just says straight away start design and prototyping. Correct.
Hmm.
So depends on what aspect, like much like your end-to-end applications, right? I will have UI, I will have server side, I will have the middleware, and those things. So choose, pick and choose what you want. Like you want to do the storyboarding part, okay, you want to actually start with some UI toolkits for 3D programming like Unity, or there's there's a JS library also called as Babylon, right? So if you want to experiment with those to get a view of how to operate with 3D objects, or how to program 2D objects and make them 3D, right? So those sort of things. So if you want the UI part of that, go for the UI frameworks, which is Unity, Unreal, Babylon, MRTK. Okay. If you really want to start with the developing the, I mean, providing the hand gestures and all, so it is more of your AI part, which is cognitive, speech, text, and stuff. So pick and choose your area of interest, and you can start right away. Right away.
And there is one more question. How can we have an Azure also work on Azure Digital Twin?
That's a
Oh,
very good
this is
question. Yes, yeah, that's a very good question, right? With the
with
AR and
AR and
VR world.
VR.
Yeah.
Yeah.
So how can we work on? Yeah. So this comes, with the IoT actually. So digital twin, right? So people who have worked on IoT, edge, or event hub and IoT edge devices and all, will know that when you go to that IoT device or edge devices, you will have a digital twin there, right? So which means what the digital twin does basically is, if your device is in a disconnected mode, that twin is actually the exact replica of that device onto your IoT. right? So that is helping you sync basically when the device goes offline online, right? So yes, we can do that, right? I mean, basically this is for AR VR applications wherein they will communicate, so devices communicating with each other over the IoT hub, correct?
Hmm.
So yes, we can get to work on that also. So I will, I mean, Walking Voyager, interesting name. So for you, I'll ask you to go actually and look at the documentation of Azure IoT, and they have a end-to-end demo of deploying your models on IoT edge, right? So machine learning models on IoT edge, and that will give you a sort of understanding of how to do that. The tutorial which is there on Microsoft talks about, I think, some
Yeah.
classification use case. You can try that with computer vision as well.
Yeah, that's true. That's true. And there is a lot of connectivity with amazing services apart from Azure as well. Like you can connect Amazon Redshift to this Azure
Yeah,
services
yeah, yeah,
also.
yeah, absolutely,
Any
absolutely.
integration is here. Like if you want to scale much more, use Azure Arc. Scale it to the hundreds extent. It works still the
Yes,
same.
yes,
Yep, I think
correct.
this is my community. So bioinformatics community. So yeah, I asked the question. So the above one also is me. So
Okay.
yeah. How are the best possible applications being developed in the industrial application? Will the code and the simulation make sense when we are collecting some data for the research? It's
Right, correct. Like, so for example, now you are, let's say, you and me are developing a waste recycling application, right? And that
mm,
is currently, so this disconnected model is currently operational. So one of my very good friends, he's an entrepreneur sitting here in Singapore, and he's controlling the waste treatment project in India, right? So
mm,
his data gathering and his simulation teams, they are tracking the, GPS devices are tracking the movement of some garbage collection trucks, and the data on all of that, right? The data is transmitted to IoT hub. Programmers sitting on in Singapore here, they are doing those, they have devices here which are reading from those hub, I mean, which are reading from, getting messages using MQTT and AMQP from the IoT hub, and all the coding process goes on here in Singapore. This is being currently worked on, and any problem with the GPS device, or the GPS device goes down, or there's some issue, then they are using DFF, digital field force, digital field services, 365 field services, to sort of give remote assistance to those guys back there,
mm. Yes,
offshore.
that's true. That's true. And also, Aman is asking a question: how much knowledge should we have of graphics programming and Unity for making a project on AR and VR, or it's just hidden layers? What is it all about?
Easy, you need to have, quite, I mean, you need to delve down deep into, I will say, at least for, like, 15-20 days. So it's not like
Hmm.
Angular, like you go one tutorial and you are done, right? So as I said, you need to have a hold on lot of things, especially like the
Hmm.
coordinate system, their interaction with objects. So getting to know normal 3D movement in 3D itself is a challenge. So we are programming, movement of a person from one floor to another in our current project, and that itself is proving to be a challenge, because I mean, I won't move only in one particular orientation, right? I mean, if I'm moving straight, I won't just move straight. I will sway in some or the other way, and then, having those corrections and things. So yeah, you start with Unity, start with Babylon, and you will come to know the challenges. So it's not straightforward, right? So see, these things are basically expertises in themselves. So you say that I am a game developer, or I am a 3D, 3D graphics developer. So that's a skill in itself, right? I mean, there's nothing like a
Hmm.
full stack developer who can also do 3D UI and also do 3D computer vision, data science programming, right? So those are niche skills in themselves. So that's what I said. Pick your side of the poison and start start your journey. So yeah, I mean, those are extensive technologies, right? I mean, I've barely scratched the surface of it with Babylon and Unity.
Yeah,
But
I
yeah,
think, yeah.
it is not. It will take a lot of investment on your side if you really want to start with
Yeah,
that. Start developing your own prototypes. Huh? That
yeah,
is
like
basically
that's what
what
it
it
is. Yeah. Like if you want to really do it, choose it before 5 years of regretting. Like you did one thing for 5 years and now you're regretting that I didn't do that. Like to just keep that 5 years for that only, then afterwards you will be the best in that somehow.
is. Right. Correct.
Yeah, I think the same one. I think the non-entertainment, lot of things. I think
Yeah, I
Aman, ma'am,
told you,
anything that
right?
you want to say
Surgery
apart from?
for your
Yeah.
correct for your surgery. Like if you have some in pandemic times, you imagine like the doctor who couldn't be there to guide the intern. So then, with the help of mixed reality, he could actually get a 3D view of what the intern is doing and guide him through the surgery. So that's
Hmm.
another mixed reality application, correct? Or in your research industry, so getting someone who's senior come and look at your microscope design and see like why this is not fitting, or why that microscope
Hmm.
is not or telescope is not giving the correct magnification, correct? So those kind of things.
Yeah, I think perfect. I think, guys, any questions apart from this? Oh, yeah. How can we work on? Oh, we'll see. I'd ask one more question. How can we work and integrate with app? That's our question. Sorry, I didn't notice that. Sorry, we'll see.
Yeah, exactly, right. So yeah, so you build UI in Unity, then you integrate it using so actually if I'll talk of this with IoT edge and IoT Azure IoT. Okay, so you have a lot of ecosystems working there, so you can deploy individual modules as I mean individual applications as modules there basically on the
Hmm.
edge, and on as modules on one particular edge device, and that's how they can interact with each other. So I mean, it's a very vague question, right? What does it mean? How can we work and integrate with app? So you're
Yeah,
saying an
like I think.
existing app.
Yeah, I think probably something like a hot deploy or hot reload or something kind of a stuff. Like we have a DevOps engine somewhere and we have an integration somewhere which we are putting. Probably we might have a tool, something
Okay,
like that.
okay.
Yeah, I think probably fourth week of the series, yeah, I think probably you'll get to know that because I'm also working on that part only. So yeah, I think thank you so much, folks. Thank you so much for all these questions and all the patience that you had for this session. And thank you so much, ma'am.
Thank you guys, have a good week, good weekend, and see you next
Yeah,
week.
see you next week, guys. Ma'am, wait